Coding algorithms for interview preparation. In today's competitive tech landscape, mastering coding algorithms has become essential for professionals aiming to excel in technical interviews. Whether you're preparing for roles at top-tier companies or looking to enhance your problem-solving skills, understanding algorithms is crucial. The journey through algorithmic challenges can be both rewarding and demanding. This guide explores key strategies, common problems, and practical tips to help you navigate the world of coding algorithms effectively. Fundamentals of algorithm design. An algorithm is a well-defined procedure that takes some value as input and produces an output. Understanding its core principles allows developers to create efficient solutions tailored to specific tasks. At its heart, algorithm design revolves around identifying patterns within data structures. By analyzing these patterns, programmers can devise methods that optimize performance across various operations. There are several approaches to designing algorithms, including brute force techniques which solve problems by checking all possible solutions exhaustively. Greedy algorithms make locally optimal choices at each step in hopes of finding a global optimum solution without backtracking later steps. Brute force solves problems comprehensively but may lack efficiency due to high time complexity. Divide and conquer breaks complex problems into smaller subproblems that can be solved independently before combining results. Dynamic programming stores intermediate results from previous computations to avoid redundant work during future calculations. Backtracking explores potential solutions incrementally while undoing decisions when they lead towards invalid paths. Common data structures used in algorithms. Data structures form the backbone of any effective algorithm implementation. Choosing the right structure significantly impacts how efficiently your code processes information and solves problems. Arrays provide quick access times through indexes but require contiguous memory allocation, making them less flexible compared to other options available today. Linked lists allow dynamic resizing yet suffer from slower traversal speeds since elements aren't stored contiguously in memory space. Trees organize hierarchical relationships between items, allowing fast searches using binary search trees specifically designed for such purposes. Graphs represent connections among entities, enabling powerful network analysis capabilities vital in many real-world applications ranging from social media platforms to logistics systems. Stacks implement last in first out, LIFO, behavior useful in scenarios involving recursion or depth-first traversals where maintaining state becomes critical. Queues follow first in first out, FIFO, order beneficial for managing task scheduling. Queues or breadth-first graph traversals requiring orderly processing sequences. Sorting algorithms overview. Sorting lies at the foundation of numerous computational tasks, providing structured arrangements necessary for further manipulations or analyses upon datasets. Bubble sort compares adjacent elements, swapping them whenever their ordering doesn't conform correctly. However, it suffers from poor scalability issues, limiting applicability, mainly confined within educational contexts. Insertion sort builds sorted arrays, iteratively inserting new elements into appropriate positions, ensuring minimal comparisons required relative to other similar methods. Merge sort utilizes divide and conquer strategy, splitting unsorted portions recursively until reaching trivially manageable sizes, then merging sorted halves systematically. Quick sort operates similarly, employing pivot selection, dividing elements based on comparative values followed by recursive sorting of resulting partitions. N-squared bubble sort, insertion sort, suitable only for small datasets due to quadratic growth rate affecting execution speed drastically. N-log and merge sort, quick sort, preferred choices handling medium to large scale inputs efficiently. N-counting sort, radix sort, specialized techniques applicable under certain constraints regarding element types or ranges. Searching techniques in algorithm development. Efficient searching mechanisms enable rapid retrieval of desired records, enhancing overall system responsiveness, particularly noticeable in database management environments. Linear search sequentially probes every item inside collections, stopping once target found, though potentially inefficient given worst-case scenario implications. Binary search leverages ordered lists utilizing midpoint evaluation, repeatedly narrowing down viable candidates, thereby achieving logarithmic performance characteristics. Hash tables offer constant time lookups, transforming raw keys into indices via hashing functions, although collision resolution strategies must carefully considered alongside load factors maintained optimally. Tree structures facilitate prefix-based queries commonly employed within autocomplete features present nowadays across online search engines, facilitating faster keyword suggestions. Dynamic programming concepts explained. Dynamic programming simplifies seemingly intricate optimization problems by decomposing them into simpler overlapping subproblems whose outcomes get cached for reuse, minimizing repeated computation efforts. This approach relies heavily upon recurrence relations, expressing current state transitions, mathematically capturing dependencies, accurately reflecting actual conditions encountered frequently. Prioritizing memoization ensures previously computed states remain accessible, accelerating subsequent requests, eliminating redundant recalculations, unnecessarily consuming resources otherwise. Fibonacci sequence serves classic example illustrating benefits derived from applying DP principles, reducing exponential runtime down linear levels, dramatically improving tractability aspects associated therewith. Knapsack problem exemplifies another canonical application, showcasing how careful resource allocation decisions yield maximal profit margins constrained within fixed capacity limitations imposed externally. Understanding time complexity analysis, evaluating asymptotic behaviors, helps assess scalability properties, determining whether proposed implementations will perform adequately amidst increasing workload demands placed against them. Big O notation quantifies upper bounds, defining worst-case scenarios, helping predict growth trends observed over progressively larger input sizes regardless external variables influencing operational costs indirectly. Constant time complexity denotes operations executing uniformly irrespective varying dataset dimensions, implying consistent latencies experienced consistently throughout executions thereof. Logarithmic complexities grow slowly, becoming increasingly advantageous, especially concerning large-scale deployments necessitating optimized processing routines prioritized accordingly. Quadratic runtimes indicate procedures expanding rapidly, necessitating caution exercised particularly when selecting algorithms intended for extensive usage scenarios involving massive volumes handled simultaneously. Exponential curves depict highly inefficient methodologies generally avoided except special cases where alternative avenues prove impractical despite inherent inefficiencies born thereof. Mastering recursion in coding challenges. Recursive functions call themselves repeatedly resolving base case conditions first, thereafter proceeding upwards layer by layer, constructing final answers gradually assembled piecewise fashion. While elegant, often producing clean readable code, sometimes hidden overhead exists related stack frame allocations, risking overflow errors triggered unexpectedly under particular circumstances. Factorial calculation represents straightforward instance demonstrating basic mechanics involved wherein function invokes itself decrementing argument until reaching zero, serving termination signal. Fibonacci series showcases additional illustration revealing recursive nature embedded deeply, requiring separate treatment, accounting overlaps occurring naturally during successive calls made recurrently throughout entire process. Tree traversals highlight significant use case, emphasizing necessity thoroughly understand recursion's intricacies because incorrect implementations could result in infinite loops, trapping program indefinitely unless properly managed meticulously beforehand. Preparing for technical interviews with algorithms. Succeeding in technical interviews requires strategic preparation, focusing not merely memorization rote facts, instead cultivating deep conceptual comprehension capable translating abstract ideas concrete implementations effortlessly. Practice solving diverse range problems daily, exercising muscle memory, reinforcing fundamental constructs internalized intuitively rather than relying solely passive learning modalities alone. Reviewing standard templates assists recognizing familiar patterns, facilitating quicker identification, applicable strategies addressing novel situations encountered spontaneously during live assessments conducted remotely typically. Engaging actively participating discussions forums communities fosters collaborative spirit encouraging peer feedback refining personal technique continuously adapting evolving standards prevailing industry norms currently. Simulating realistic interview settings enhances confidence level exposing individuals' genuine pressure conditions mimicking authentic experiences replicating atmosphere precisely expected faced officially. Advanced topics in algorithm optimization optimizing algorithms involves fine-tuning existing designs leveraging advanced mathematical theories probability theory game theory amongst others seeking marginal gains yielding substantial improvements collectively. Heuristic methods approximate near-optimal solutions sacrificing guarantees completeness exchange flexibility trade-off favoring expediency over absolute accuracy acceptable contextually depending priorities emphasized foremost. Approximation algorithms construct close enough estimates satisfying predefined error tolerances sufficiently good practically sufficient meeting requirements imposed externally without violating underlying assumptions inherently assumed. Randomized algorithms introduce randomness deliberately manipulating decision points generating probabilistic correctness assurances relaxing deterministic expectations usually demanded traditionally. Parallel computing distributes heavy lifting tasks across multiple processors concurrently speeding up completion times appreciably particularly benefiting compute-intensive operations requiring parallelizable components amenable. Decomposition suitably. Resources for learning and practicing algorithms leveraging curated resources accelerates proficiency acquisition substantially reducing initial steepness curve encountered newcomers unfamiliar territory initially. Online courses provide structured curricula guiding learners systematically covering foundational topics progressing steadily towards sophisticated material progressively building expertise cumulatively. Books serve invaluable references offering thorough explanations grounded solid theoretical basis complemented illustrative examples aiding visualization abstract concepts concretely. Competitive programming platforms host contests fostering skill development through challenging puzzles pushing boundaries testing limits regularly updating leaderboard rankings motivating continuous improvement pursuit excellence relentlessly. Community forums facilitate knowledge sharing exchanging insights troubleshooting difficulties collaboratively nurturing supportive ecosystem promoting mutual growth professionally personally alike. Conclusion mastery of coding algorithms equips developers with indispensable tools navigating complex software engineering landscapes confidently confronting multifaceted challenges arising inevitably throughout careers spent crafting digital innovations shaping tomorrow's technologies. By diligently practicing regularly reviewing fundamentals exploring cutting-edge advancements staying abreast latest developments continually honing craft individuals position themselves advantageously securing coveted opportunities awaiting those prepared adequately ahead of competition fiercely vying same rewards eagerly anticipated universally. HTML